right, so last time, just to reiterate what we hit last time, was instead of and, we use ampersand. And typically we're actually using two ampersands, which technically has another meaning. A single ampersand means always evaluate both. The double ampersand is the short circuit, which means if the first one is false, there's no sense in looking at the other operand, right? And I feel like most of the time you're using double ampersand, but there are cases where you might want to ensure both are looked at. Because imagine you have a function. If this doesn't make perfect sense to you after I'm done explaining it, don't worry. But if you have a function that returns a Boolean, so if some condition and the result of this function are true, then do something, right? It might be important that, so imagine that that function that returns a Boolean has a bunch of side effects. First of all, we'd want to avoid that in the first place, but sometimes you're just kind of, it is what it is. You've got a function that has a bunch of side effects that needs to run. If you use the double ampersand on an and you saw false and that function that needs to run, it ain't running. The double ampersand says you don't need to bother checking out the other side. I'm saving some time. So if that's the case, that's when you would use like the single ampersand. Similarly with or. And if you're wondering, yeah, what is that button? What's that key? It's above the enter. It's shift that slash above the enter. That's how you get that little pipe. And instead of writing out not, you use exclamation point. Any questions about the Boolean stuff? Awesome. So while loops. While loops are basically the same in Java as Python. You look at it and you're like, well, the syntax is different. And then you look at it a little longer and you go like, but is it really? So what do we have? A while loop. So here's a counting while loop. It's a while loop that's just going to run with a counter, right? That's all. Nothing particularly special. So on Python, I've created my counter C. While C is less than 10, print C is now whatever, and then increment C, right? Remember, the plus equals means C equals C plus 1. Here we go in Java. C, it's going to be a variable, but of course it's Java. We need to specify the type. So we say int C equals 0. And then while C is less than 10. The difference here on that line is the fact that the expression needs to be in parentheses. It has to be. In Python, you didn't need to. You could have, it didn't matter. In Java, it has to be in parentheses. And like with functions, instead of the indent mattering like it does in Python, like you don't have the colon, instead you have the open squiggle, the open brace, and then when you're done, you close it. Open, close, as opposed to indent, unindent. That's the key difference there. The print is basically the same. One thing interesting here is the C. You'll see it says C++. Plus equals 1 would work here in Java too. It's fine. But plus plus is even more of a shorthand. That means add 1. Same with minus minus. Minus minus means decrement 1. So in Java, I could say C plus equals 1, and it would work. Or I could say C++, and that would also work. It's a shorter shorthand for when it's 1. But of course, plus equals works if you wanted to say plus equals 10. Then it would add 10 every time. Plus plus is always only ever going to be add 1. Any questions about that one? So here's a slight variation. Here, at the end of the day, these while loops are effectively doing the same thing, checking some Boolean condition. While the Boolean condition is true, keep running. But instead of like a counter, well, now it's just using some Boolean flag. I've got some stop flag that's set to false. I've got some C equals 0. Well, not stop. Same thing, but then I've just got this check. If C equals 5, stop's true. It's the same as in Java. But of course, instead of typing out not, I put exclamation point, stop. The parentheses are there. There's an if statement, whatever. This is a contrived example, but I'm just showing you examples. Questions? Remember, raise your hand, stop me if you have a question. Yeah?
Do you not have to string C when you add it?
Let's find out. Nope. So if I run, oop, apparently I did it twice. I've changed it so it should run faster, but of course it's not. So you were there when I did it too, when I made the change. It's a really complex program. It's difficult to build. So I will also say that, oh my God. All right, so I will also say that the way I'm printing, what is happening? So evidently the answer is no, we don't need to. It's fine, it's smart enough to just kind of do it for you automatically. That said, remember how in Python I was kind of like telling you to do F strings? How F is like a formatted string, it's a little nicer. Typically, there's nothing wrong with this. This is great, it's quick and dirty, it does the trick. But usually if I'm making a string where I'm combining variables and whatnot, I'm going to use like string.format, which is effectively F strings. So I wouldn't actually do it this way. But to answer your question, no, we didn't need to convert it to a string. Which is kind of funny because like you'd think like, well, you know, Python's the one that's always kind of like making assumptions for you and simplifying things at the risk of potentially going wrong. But in this case, Java was more like, yeah, whatever, kind of backwards. So now here's a for each loop. So this is like your typical loop in Python. I've got some list, A, B, C, D, for C in a list. Remember, for each thing in a collection of things. It's like a for each loop. Print out C. And remember, anything you do with a while loop, you can do with a for loop, whatever. It's just how you go about doing it. Here's how you would do it in Java. So first of all, again, there's no list, so instead I just made an array, which is going to act as the list. Great. And then for C, so the difference here is, okay, we have for, we've got the parentheses, we've got our braces, like the squiggly brackets. But really, the key thing here is, instead of in, we use a colon. This is the name of the collection. This is the name of the collection. This is the variable that's going to hold the current value that changes every time the loop runs. C is going to be like the current thing. But of course, you're like, but there's char in front of it. Well, yeah, because we need to specify the type of any variable when it's declared. So for each character C, and I'm doing character because these are characters, this is fairly atypical. You don't usually, like, characters don't pop up very often, but they can. But for each character, C in an array, there you go. Yes?
Well, the fact that the variable is C and there's a C in the list or in the array.
It's arbitrary. I could have called this, let's just convince ourselves. It'll work. Well, we'll find out if it'll work. I don't know why this is taking so long. This is insane. Maybe because I'm recording and this laptop's old. But yeah, just like in Python too, it didn't actually, it's just the name. There you go. That took a long time to run. So here is so really in Python, all we ever really had was for each loops, which is kind of interesting because sometimes you just need like a for loop to count. But then you'd say like, well, no, we had those in Python. We would say like for I in range 10, and that means like go from 0 to 9, right? Or if you wanted it to be from like 10 to 20, you would say range 10, 20, right? So that's how you would do it. But really, that was actually just a for loop, because range is actually like a function that returns an iterable object. That's effectively, you could think of it as a list of the numbers 0 through 9. If you said range 10, it's basically giving you back a list of the numbers 0 through 9. So for each number in that list. So at the end of the day, it really was the same thing, but you don't really need to think of it like that. But often we want just like this counting for loop. It's a for loop, but it's just going to count. So here's how you typically do it in Java. For integer I starting at 0, while I is less than 10, do the contents, and then after each iteration of the contents of that loop, add 1. Why is it add 1? Plus plus. Plus plus means add 1. If I were to say I equals I plus 10, or I equals I plus 2, this would only run 5 times, right? Because 0, 2, 4. But that's how you do it. This is the common pattern. Technically, all that really matters in here is that you have a Boolean condition. But really, this is how you commonly, like almost always see your for loops. In fact, if I go to IntelliJ and I type for tab, no, hold on. It'll be like, oh, you want like an iteration one? I say tab. It'll be like, well, what do you want to call the variable? I? Like it'll like autocomplete for you with the basic template, whatever. It's a very common pattern. You'll have this memorized in no time. Yep. So yeah, this is the starting condition. This is the run while condition. And this is like, well, what's going to happen at the end of every run? I mean, if you compare it to the for loop or the while loop, it's actually like, it's the same idea, just the syntax is different. But it's functionally the same idea. With the while loop, you would usually have, like, if you had a counting while loop, you'd have some initialization outside the loop, while the condition, you've got your loop stuff, and then like, well, like what's happening at the end of every run of the loop. Well, the for loop is really just syntactic sugar for that. It just makes it slightly nicer syntax. Initializer here, condition here, step here, and all the loop stuff is there. And raise your hand if you remember what I mean when I say syntactic sugar. No one raised their hand, just one person nodded. I'll remind you, all it means, I remember for the longest time, I heard profs and other programmers use that word, and I'd be like, yeah, I know what that means. I had no idea what it meant. And all it really means is when the syntax, like Python is full of syntactic sugar. It's when the syntax is just nice. I don't know how else to explain it. It's like a nicer syntax. For example, this for loop it's syntactic sugar for that while loop. There's nothing wrong with that while loop. It would be functionally the same, but it's just a little bit nicer. And often it's like when the syntax is like more natural, we would be like, oh, that's like syntactic sugar. That's nice. But it's not functionally different. It's just syntax. That's all. So it's nice because it's like, oh, it's sweet, I guess. I didn't come up with it. So Java conventions now. So I just blitzed through a bunch of stuff. Obviously, this is not an exhaustive list. And to reiterate what I said last time, I'm not showing you this so you can leave today and be like, I now know Java. No, that's ridiculous of an expectation. And if you're putting that expectation on yourself, that's ridiculous. What I'm showing you is, this is what I was saying last time. What I'm showing you is basically what you don't know. So when you need to figure out how to do what you don't know, you at least know what you don't know. You've got a point of reference. You're aware of what you know. You can go back here and look it up if you need, or you can go back here and at least be like, yeah, so how do I do that in Java again? But at least you now know what you don't know, so you can learn more when you need to. Because remember, that's basically what programming is. It's kind of like figuring it out as you go. So now for some conventions. These conventions are not functionally important, but for our purposes in this course, let's pretend they are. You must follow these conventions. If you don't follow these conventions, the Java police will come to your door and they'll be mad at you. So class names always start with an uppercase. Funnily enough, on Caddis, the default class name is hello, and it's a lowercase. And that is horrendous that they do that. I can't believe it. Maybe they'll fix that one day. But your class name has to start with an uppercase. Now, it doesn't have to, but it has to. Okay? Also, if you didn't notice that yet, the file name must match your class name. So this right here is called main. We can call this thingy, right? And it's going to be mad at me, and it's because this isn't called thingy. So I can rename this. Thingy.java. Well, now it's happy. But your class name must start with an uppercase. This right here cannot start with an uppercase. If you do, it ain't the main method. It's case sensitive. Main must be lowercase. Class name, uppercase. Remember, it's just the convention. It doesn't have to be like that, but it has to be like that. Okay? Functions and methods use camel case. Python use snake case. That's when your words are underscore separated. Camel case is like this, some function, some other function. Always start with a lowercase. Unless you are making a class or you are referencing the name of a class, you use lowercase. Uppercase is reserved for classes and constants. You always start with a lowercase, but every subsequent new word that you would be using starts with an uppercase. Make sense? So again, you don't have to do this, but you have to do this. Same with variables. Camel case, always start with a lowercase. Okay? Constants are all uppercase and snake case. That's actually the same convention as Python. This is the convention across multiple languages for constants. It's the leave me the hell alone convention. Cool? Yeah? There are obviously more conventions and things that we'll learn along the way, and I'll point them out. Throughout this course, like I was saying before, the purpose of this course is to emphasize data structures and their respective algorithms that go with them so you can solve problems. Those are the explicit learning objectives. The implicit learning objectives are going to be obviously you're going to become better programmers because you're more used to programming, you've got more experience, you're going to learn some various algorithms. You're going to learn a little bit about how to think of how good is this algorithm. And of course, Java. You are going to be learning some Java along the way. Now I can stand up here and say, this really isn't a course on Java all I want. But there's going to be chunks of time where you obviously you need to know Java, so I'm going to have to show you some of those things. And a lot of the stuff from Python to Java is going to be basically the same, but there might end up being some Java-isms, this is a new thing that Java kind of wants you to do. I'll make it very obvious as we go. So, right, so if at any point during this course you're thinking, uh-oh, how on earth I'm going to remember all of these differences? You're doing programming wrong. You're doing it way wrong. And you'll notice that text is blue. It's blue because it's a link. Where do you think this link is going to take you? With a specific example, actually. For example, how to use loops in Java. This is how you program. You don't program by going, oh no, how do I do a for loop? I don't know, No, you go freaking figure it out. Because that's how it is. New programmers, I think they think way too highly of experienced programmers. Because the difference in how you go about programming between a new programmer and an experienced programmer is just how okay they are with going to rip crap off the internet. Experienced programmers just know oh, that's just what you do. New programmers are always I don't know, I feel like I'm kind of cheating. It's like, well, okay, yeah, there's borderline in a university setting what is cheating, of course. You do your work. But a lot of programming at the end of the day is like, okay, I've got this problem, I need to solve it. And you got to remember, if you're in 161 and maybe 162, your specific questions, at least at the beginning of the semester, you can go Google it and you might find an exact solution to your problem online. Great. But it's not going to be very long where, we know enough where you're going to search a problem and you're not going to find an exact solution for your problem. It ain't going to happen. But you'll find a solution for a similar problem. And the ability for you, this is really what separates, this is what makes a good programmer. I've got a problem, I don't know how to solve it, but I've been Googling away and I found a solution. It's not quite the solution to my problem, but I can see how it's kind of similar to my problem. And if I can look at that similar problem, take what's in there, modify it, change it, hack it around a little bit, and make use of it to solve my problem, you're a good programmer. And let's take a moment and think about the necessary skills you have to have in order to do that. You need to first understand what the hell you're trying to do. You have to understand what's wrong with it. And if you're like, well, yeah, no shit. You want to see the 161 exams? There's a lot of people that don't know that. So that's not trivial. That's tough to do. So you got to understand the problem you're solving, understand the problem you're having with the problem you're trying to solve. You understand the problem someone else is having and the problem that they're trying to understand, and you understand how to take their solution to their problem and change it such that it works in your problem. The amount of understanding you have to have in order to be able to do that effectively is insane. If you can do that effectively, you're a good programmer. Just because of the requisite knowledge you have to have. Every once in a while you can get lucky, you copy and paste and it just worked. That ain't going to happen very often. All of those things, if any of those individual things felt trivial to you, you're wrong. They're not. If you find that they're trivial to you, well, fantastic, great, I'm happy for you. But you have a bunch of non-trivial things, you put them together, it's even worse, right? Like it's a complex thing to do. And if you can do it, that's a good thing. So make use of resources available. How do I do this for loop? How do I make an array such that I can reverse the contents? Like these are questions you can start going to try to go do your own research to figure out how to do it. How do you get better? Practice. At this stage of this semester, someone's saying like, yeah, okay, I'm kind of getting it, but I still want to get better at Java. Okay, practice. Yeah, but how else do I do it? Just more practice. And then if you ask again, I'm going to say more practice. Just practice. It's the only way. It's like I say before in 161. You can go watch every Java programming tutorial there is on YouTube. There's probably millions and millions and millions of hours of Java programming tutorials on YouTube, right? You can watch every single one of them. That's great, but you're probably not going to be able to sit down and do a lot. You actually have to do it. You can go watch every piano tutorial there is. But unless you're actually sitting at a piano playing, you're not going to get better. Just practice. No one's expecting you to read it and understand it like that. It doesn't work like that. It never will. And it hasn't. Yeah. Any questions? Rant over. Any questions? All right. Okay, objects review. All right. So all of the stuff we just showed you, I was showing you like kind of like the base core things. Variables, types, loops, functions, ifs, right? But I didn't talk about classes yet. I mean, I did in the sense that everything needs to be in a class, but we didn't make our own like objects yet, right? So let's see how to do that in Java. That's what we're going to do. And we are going to compare to Python for a little bit of this topic, and then I abandon it as we go. So I want to make an object. Defining objects is similar between Python and Java. It really is the same general pattern. You start the class, you've got a constructor, you've got some attributes, and you've got some methods. It's the same thing in Java. Most of the differences are syntax related, and objects are things in general. Like an object is a thing that typically contains data, can do some action, or can be acted upon. Each or all of these things. Now, I was very careful. Yeah, okay, and often when programming in Java, you're going to have objects interacting with each other a lot. And I was very careful in 161 to give you a design philosophy. So objects are a great way to consolidate data and functionality together. But that doesn't mean we necessarily want to combine data with functionality. We can combine data together and functionality together, but doing it both can be hairy and tricky. Sometimes we want our data to just be data, and we want our functionality to just be functionality. That's a good thing. We like that. Now, having a bunch of data that has corresponding functions, I mean, that's going to be a lot of what data structures are. But as a general design philosophy, a lot of people tend to want to separate their data and functionality, very separate things. And you will see this design philosophy in the assignments that you're going to be doing, so just FYI. So just because we can combine data and functionality doesn't mean we should, but we can. This right here, when it comes to design of your code, these are like engineering and implementation decisions someone needs to make. This is not something you're going to be experts in at the end of 162. Like everyone's always learning how to design things better. When I'm talking about design, I just want to give you like ideas, and maybe if you follow this strategy, it might be beneficial to you, but this is something you're going to learn for the next few decades if you keep doing this. All right, so all objects have properties. This is like the data. We call these fields. They're basically just the variables, but they belong to an instance of an object. Like for example, you have a first name. And you have a first name, right? You both have first names. They might have different values, but you both have first names. So that's like what this is. And then there's behaviors. This is what the objects can do. These are called the methods. This is the functions that you can tell the object to do. So if you're thinking back to like the country catalog assignment, the country objects was just data. I don't really think there was much functionality associated with them other than like defining a quality in a toString or something, right? So it's just data. And it had fields like country name, continent, right? But it was the country catalog that had more functionality associated with it. There were the methods that you would call like add a country to the catalog, for example. Okay, a class. Every object is defined by a class. The class is like the blueprint. And if I want to make an instance of a country, well, I can make an instance of a country, but it's based on what was defined in the class, right? You remember this, hopefully. The class defines what it means. For example, you could think of a human class with the fields first name, last name, and methods eat and go to bed, whatever. If I make an instance of a human, they will have all these things. But then I can make an instance. I can make multiple instances of a human, each with their own particular values. If I make a Bob Smith human, and its first name is going to be Bob, its last name is going to be Smith, and when I say, hey, my instance dot eat, it would tell that specific instance, Bob Smith, to eat. Not all of them, only the one. Yeah? It's review, but of course, if you have questions, ask. Yes? Yes. So this is terminology programmers will often like mash together. So really, an instance of a class is an object. Yeah, there you go. Yeah. But I'm going to warn you that I might refer to a class as an object. I might refer to an instance as an object. It's all going to be context. If you're thinking, oh no, the fact that programmers are so loosey-goosey with this terminology goes to tell, it really doesn't matter that much. You'll figure it out from the context. You'll figure it out quickly. Other questions? All right. All objects of the same class have the same fields, but their values can differ, like I said. Everyone in here has a first name, but chances are a lot of you are going to have different first names. Say objects of the same class have the same methods, but calling methods on an instance only calls that one. So, classes and so why do we do this? Well, we don't have to. There are styles of program. When you're making objects, when you're writing classes to make objects, and you're going to have your program that's basically a series of objects interacting with one another, well, this is object-oriented programming. It's a style of programming. But you don't have to program object-oriented. Python, you don't have to. You can write code that is object-oriented. In Java, you basically are always writing object-oriented. You can pretend you're not and just hide most of that stuff. But at the end of the day, it's object-oriented programming. And there are languages like C where there's really no such thing as objects. Closest you have is like a structure, but that's different. So why do we do this? Well, back in the 90s, this was a big deal. Since then, people are now not so convinced that it's necessarily a great way to program. There's nothing wrong with it, but it's not the end-all, be-all. It's not the best way to program. But classes, look, we write functions to group code together, right? Right? We do that. And it's nice when you have a function, like a complex function that says, do my complex thing. And when I call it, and it says, do my complex thing, and maybe there's like 50 lines of code in that function, I don't know, but it's complicated, but it does what it does. It facilitates abstraction really well. I can just call that function. I don't need to think about the 50 different things that function needs to do. I can just call that function. It's great, right? So it facilitates abstraction, right? In the same way that, I know I talked about this in 161, if I tell you to lift your arm, what do? You just lift your arm, right? If I tell you to go open your fridge, what do? Well, you walk to your fridge, you grab it, and you open it. You're probably not really thinking about it a lot. But think of all the steps that went along the way. Think of all like the muscles and tendons that were contracting and whatnot in order for you to move there. Think of all like the neurons. There was a lot of things going on under the hood in order for you to move to your fridge and open it. But thank God we interact with our world at a much higher level of abstraction. I don't need to think about firing neurons. It just happens. How many of you, what do I say here? How many of you know exactly how your HVAC system works at your place? If you raise your hand, shut up. No, you don't. Every year there's some asshole that's like, I know exactly how to build a car. Okay, go do it. Right? So you don't know how it works. But do you need to know how it works in order to turn the thermostat up? No. Because the way you interface with your HVAC system is your thermostat. Turn it up or turn it down. Maybe you're hitting buttons. I don't know. Right? That's how you interface with it. That's how you tell it how to work. You are interfacing with your HVAC system at a fairly abstract level. I want it to get hotter? Turn it that way. I want it to get colder? Turn it that way. How much of crap is going on under the hood in order for that to work? Well, a lot more than just this and that, right? But the point is, you didn't need to operate at that lower level of abstraction. We operate at a higher level of abstraction. And like functions facilitate abstraction, classes facilitate abstraction another level. Because we can have like functions in the classes, methods, and they're grouped together. It just facilitates abstraction really nicely. So we like it. So at a high level, your classes are going to contain your fields, that's the data. Your methods, that's your functionality. And a constructor, which is just a method. It's just a method. But you remember from Python, the constructor was like a special method that kind of like did all the setup code for you, right? And if you remember, you didn't actually need to write the constructor, but if you didn't have a constructor, your classes were usually pretty boring. So in Java, class code is written in a file that has the same name as the class. It has the .java file extension. So the human class would be in a file called human.java. If I wanted to write a human class, I would create a new file, and I would say, OK, human.java, and I would start writing the class. So what we're going to do is with an example. We're actually going to do an example where we build a collection. And you might remember from 161, a collection is not a simple object. Simple objects were the examples that we did where we made like a square, and then a sphere, or a circle and then a sphere, right? But like thinking to the country catalog assignment, you had a collection of countries. A country is like a nice simple object, but a collection of countries was a lot more complex. There was a lot more going on that you had to deal with, right? So we're going to do a collection. And I'm going to warn you, yeah, collections are tricky. They're pretty complex. It's not too bad, but it definitely is a little bit there. And we're going to work towards that. We're going to make a contact list example. At the end of the day, it's going to be basically the same as the country catalog example. But instead of a collection of countries, we're going to have a collection of like people. And we'll call it a contact list. That's what we're going to do. So I think the best way to learn this is by seeing an example. And again, you're going to see an example of how to write a class. And I'm not expecting you to leave here and be like, okay, I'm going to sit down on my computer and not reference what he did and just write a class. No, that's not going to happen. I'm going to show you so you know the ideas of what you got to know, and later you can refer back to this and look up what you don't know later. That's the idea. All right, so consider the following problem. There is a need to keep track of the name and email addresses of my friends. So there's also a need to manage several friends' names and email addresses. So I need a way to keep track of friends' information, and I also have a lot of friends I want to kind of manage as well. So to do this, a class could be made to represent a friend class, and one for a collection of friends, a contact list. So we're going to cover these topics, and we're going to start with the friend class, because this is a simple one. So we're going to start by making a simple friend object, friend class, to make instances. See what I mean? I already messed it up. So we're going to make a friend class. It's going to be kept very simple. Now, simple is good. Simple doesn't mean trivial. Simple doesn't mean like I've dumbed it down for you. No, often when you're writing your code, you want your classes to be simple. If you set out to make a complex class, maybe you really shouldn't. So simplicity is good. The only information I want this friend class to have is first name, last name, and email address. That's all I care about, right? So this is the data I want to store. So my class is going to need 3 fields. First name, last name, email address. Those are probably pretty good names for those fields because that's what I want them to store. The constructor will be needed in order to describe the setup of the friend class. So all I'm going to do when I call the constructor, all I want to do is give the constructor the individual's first name, last name, email address, and then I want to assign those values to the instance's fields. This is the same as it would be in Python. The goal is the same. Syntax is different, that's it. And the behavior, the methods I really don't want a lot of functionality. I don't want to, this really is a class that's supposed to hold data. So the functionality I'm going to define is just going to be get the information from a friend. I want to be able to get a string representation of the friend. So remember the repr? We're going to do the repr, but in Java. And I want to be able to check if 2 friends are equal. That's like your standard what you want. And also when you check equality, often you describe what you call a hash function, but I'll show you that in a moment as well. So you're like, well, there's a couple of things of functionality there, but really the functionality is more like it really is just about that data. Check if they're equal, give me the repr, whatever. And I want a way to access that information. So, setting fields and writing a constructor. So, the constructor is a super special method. And like Python, it has to have a special name. But it's not underscore, underscore, init, underscore, underscore. But we need a constructor. Well, if we don't write a constructor, we get one for free. But we're going to want a constructor here to set up our class when we create an instance of that class to make an object. So the constructor is a special one that's called automatically when an object is created, of that type is created. Typically, and also when I say class, like I say, okay, when an object of that class. So here the class I'm talking about is a friend class. But a moment ago I just said an object of that type. Class and type here can be used like interchangeably because the type of an instance of something of that class, it's the same thing. It's like the type of a friend object is friend from the friend class. So class and type like mean the same thing in this context. All right, typically setup-related things that needs to happen for the object will be put in the constructor. In Python, the friends class's constructor and the creation and assigning of fields would look like this. So if this was Python, this is how I would do it. I would define the friend class, and then I would say def underscore underscore init underscore underscore first name, last name, email, and then, that there. This is Python. Any questions so far? Now's the time to ask. And remember, here, like on line 5, for example, self.firstName and first name are two separate variables, right? And if you don't remember, let me remind you. Just the regular first name, like on this side here, that is the parameter from that method, right? From the constructor, right there. This and this, these are the same. They have local scope. They only exist inside this method, the constructor. Self.firstName is an entirely different thing. It is a field. It is a value. It's a variable that's associated with this specific instance that's being created. So if I were to say, like, my friend equals friend named Bob, it would be that instance's first name would be Bob. Right? Questions, thoughts, concerns? There's too much blank face. I can't tell if you're like, yeah, shut up, I know, move. Or if you're like, I have no idea what's happening. So which is it? Raise your hand if you're like, yeah, whatever, I'm good. Raise your hand if you're like, oh, what the hell? No one's brave enough to admit it? You're all a bunch of liars. All right. Well, you said it. You're all good. All right, cool. So here's how we do it in Java. All right. So there is a lot to unpack here, but the meaning of what's going on is exactly the same as it is in Python. We start with that line, class friend, but we want it to be public. So it's public class friend. But you'll also notice that I have a special keyword there, final. That's not necessary here, but I included it. And I will re-motivate the use of final in a moment. But basically what this means is this class is immutable. I'm making this class, and none of the values inside this class will change once it's created. So it's not a constant, but once it's made, it's immutable. That's what final kind of like means in this context. I didn't actually need to include it there. But public final class friend. Now, unlike Python, remember in Python, if you want a variable, you just say my variable equals 10. Great, you're good. But in Java, the first time you use the variable, you got to declare it. And remember, you could do it on one line or two lines. But really, when you do it on one line, when you say like int, my int equals 5, you've actually done two things on that line. You've declared it, and then you've assigned it a value. So you said, I want an integer variable, and store the value 5 in it. When you are defining a class, we need to declare our fields. And the fields are declared at the top of your class, right under, usually if you have static ones, they're a whole other thing. But you put them there, right under the definition, like that line that says like public class friend. And you define them there. But they're private. These fields, they're only accessible inside this class. Because I want to have control. We want our fields to be private most of the time. They're set to final because, again, I didn't need to make them final here. But they're set to final because, once again, they're not going to change. So we can set them to final because we're going to pretend this is an immutable class. Their type, string, and then their name, first name. So in Python, you didn't need to declare them before you used them. In Python, you just said like self.myFirstName. And Python goes, oh, there's a new field for my class. Great. In Java, we have to say, you're going to have a field called first name. Any questions about the declaration of the fields? This is just declaring them. They don't have a value associated with them. This is just telling Java they exist. There's no value there yet, but they're going to exist for this class. That's what that means. Then we have we have our Java docs comments. There you go. But then we've got the constructor. And look at the constructor. The constructor is basically the same. There's 3 lines in there. 3 lines in there. But the constructor is public, and your constructor's name must match the name of the class. It must. So this file is called friend.java. The class name is friend, and the constructor is called friend. So not __ init, it's friend. And it takes 3 parameters. A string, first name, a string, last name, a string, email address. You'll notice that, like in Python, we needed self at the beginning of everything. We didn't need it in Java. You don't need self there. The this keyword is the same as self, though. And I do not believe it's actually necessary here. I think Java's smart enough. But this first name and this first name are the same. Let me say that again. The first name from the parameter list, that's these things. And the first name on the right-hand side of this line 24 here, they are the same, they are the same thing. But this dot first name is the field first name. By the way, the name of this, the fact that this is first name and this one's first name, the names of those variables that they match, they don't have to match. It's just a good variable name because it's a first name. It does lead one to potential ambiguity where you're like, wait, which one it is? But that's where you can use this to like eliminate any potential ambiguity. Is it the parameter first name, or is it this instance's field that's first name? That's all. But this right here, I'm using the word this a lot, which is annoying because of the keyword this. But anyways. Questions about this? Yes?
So the parameters in this are the same as the ones in the main?
Nope. They're entirely unrelated. It's just I want to make, they're the same as what I wanted in the Python version. But main string args are entirely independent and not applicable or relevant to this right here. Unless you really wanted to connect them, but then you'd have something very specific in mind that you're doing. This is just when I want to make an instance, I'm going to call the constructor and I'm going to give it 3 values. The arguments are going to be its first name, last name, and email in that order, because that's what the code says. Yeah, what do I have here? So the class is set to public, so it can be accessed by other classes. If it was private, it wouldn't be all that useful here. It's final, since once an instance is created, we don't want to change it. We're making it immutable. I didn't need to make it immutable. It could be functionally. I could write the code such that it's not possible to change anything and still not call it final. It wouldn't really matter. But by having that keyword, Java is just giving me more flexibility as the programmer to have more control of how this code is used. It's final, it's not going to change. So if I wrote code such that, if I wrote a method that allowed me to change something inside this class, Java would be like, you said this class was final, and now you're modifying it, what gives? So that's a nice thing. The fields are declared inside the class, but not within any method, right? They are defined and declared here, but it's not in any method. They're not in the constructor. I mean, I use them in the constructor. I assign their values in the constructor. And I could access and modify their values in other methods if I wanted to. But it's the constructor where I'm using them in this example. To provide control, private, public, we are going to set the values, the fields to be private. I don't want anyone to access them anywhere without the way I want them to. The though the private fields will be readable from elsewhere with getters or accessor methods. I showed you an example of this, a motivation for this the other day. But we'll pick up here next time because we are out of time. Any last questions? All right, cool.